Welcome to the introduction to BEASI, Binary Enterprise Architecture Standard Integration, a binary software plugin for Spark's Enterprise Architect. BEASI is based on the union of three global standards: TOGAF 9.1 as the established framework and method to develop architecture, Archimate 2.0 as a unified notation to describe architecture, and Spark's Enterprise Architect, a modeling tool and repository to document and share architecture. BEASI is built to enable effective enterprise architecture work by providing properly developed structures to allow reuse of information both within projects but also across project borders. This is the second version of BEASI, version 2.0. In this new version, we created a new repository structure based on TOGAF with a pre-populated example. We have extended our support for the TOGAF ADM process, creating a project structure complete with predefined viewpoints and documentation templates. We have also added a realistic example. Finally, we have also developed a set of practical tools actually simplifying the ADM execution. These new functions span the entire ADM cycle. In the preliminary and efficient phases, P and A, we provide the support for building a repository and a project structure in an easy manner. In the architecture development phases, B, C, and D, we provide the support for automatically generating gap diagrams and consolidating the gaps that you have identified. In the architecture planning phases, E and F, we've added support for identifying dependencies between the gaps that you have defined. We have also made it possible to easily associate your gaps with new work packages, deliverables, or plateaus, or transitions as they're called in TOGAF. Finally, we've added support for generating an architecture definition increments table, basically a draft project structure based on the gaps and the associations that you have identified. This draft plan can be imported into Excel and refined further. In the rest of this presentation, we will show you how you can use these tools in detail, providing examples from Spark's Enterprise Architect.
To get started, you need to have Spark's Enterprise Architect installed and then run the BEASI installer. Once that is finished, you need to start Spark's Enterprise Architect and you will be provided with a prompt to enter the BEASI license key. Once your license key has been accepted, Sparks will open and you can create a new project. In the wizard dialog that opens, locate the binary EC technology and select the structure you want to be created. You can choose between 4 different structures: a BEASI ADM template, a BEASI ADM example, a BEASI repository template, a BEASI repository example. Select the structure you want to be created and hit OK. Please note that the structures are quite complex and creating them can take quite some time. Let's look at this in Sparks. We've installed BEASI and now we're creating a new project. And we'll soon show how we populate it with BEASI content. When the project is created, we're automatically presented with the wizard. We can here locate the BEASI templates. We see all 4 and we will select the repository example. After a while, we'll be presented with the architecture library of the fictional company Heliparts, their repository and their library of architecture initiatives. Let's start to look at the architecture repository. This repository is based on the TOGAF standard with 6 distinct areas. You can explore these areas and find examples of architecture landscape models, reference architectures, and even architecture capability models. If we now shift focus and look at the initiatives library, we will find 2 folders, one example and one template folder. Opening the template folder, you will find it pre-populated with a structure suitable for running TOGAF ADM projects. The structure aligns to the TOGAF ADM phases: preliminary, vision, business architecture, etc. For each phase, relevant views have been defined corresponding to Archimate viewpoints. BEASI also contains an example project, with examples demonstrating the work throughout the ADM phases. You will find various artifacts like concepts diagram as created in the vision phase, business function diagrams as created in the business architecture phase, data object diagrams as created in the information systems phase, examples of gap consolidation and creation of transition architectures, all with the purpose of demonstrating how you would practically work with TOGAF. One of the new features in BEASI is the possibility to automatically generate gap diagrams. Once a baseline view and a target view have been created, you just need to choose Gap Analysis from the BEASI menu, and the gap diagram is created using colors to highlight items that had been added or removed in the target view. In this example, we have created a simple baseline view and a simple target view. We make sure we select the package containing both views, and from the extension menu we select BEASI and Gap Analysis. BEASI identifies the baseline and the target and generates a gap view. We need to tidy it up a bit and add gap elements. The gap element is a core concept in TOGAF and will be used later on in the TOGAF planning phases. Once all gaps are defined in all views, it is time to, using TOGAF terminology, to consolidate the gaps. BEASI contains functionality to simplify gap consolidation. If you select a package in the Sparks project browser and from the BEASI menu select Generate Consolidate Gap Diagram, BEASI will identify all the gaps in the package and create a diagram distributing the gaps across the different phases in the project. In this example, we select a folder, from the extension menu we select BEASI and Generate Consolidated Gap Diagram. The diagram is created and the gaps are distributed across the different phases in the project. Once the gap consolidation has been made, BEASI provides functionality to derive dependencies between gaps. If you open up a consolidated gap diagram and select Derive Gap Dependencies from the BEASI menu, BEASI will analyze the gaps and highlight any dependencies. If an element associated to a gap is related to another element related to another gap, a note is added to the diagram describing the dependency. In the example, we use the previously created consolidated gap diagram. We select Derive Gap Dependencies from the BEASI menu, and the dependencies are added to the diagram. In order to make the dependencies stick, we need to save the diagram. Once all gaps have been analyzed, it's, according to TOGAF, time to build the work package structure and the transition structure. Namely, identify the projects that are going to deliver the change and how these projects are going to be coordinated. This process has been simplified by making it possible to select a group of gaps and link them to a work package, a plateau, or a deliverable. In the example, we have a diagram containing a set of gaps. We select a couple, go to the BEASI menu, and select Connect to New Work Package. The work package is created and associated to the two gaps. If we look at the menu again, you will see that it's not only possible to link to work packages, but also to plateaus and deliverables. This functionality can be used to identify the work packages, namely the projects, but also the transition architectures, how the projects needs to be coordinated. Once the work packages and the transition architectures have been identified, it is time, according to TOGAF, to define the roadmap and the migration plan. If gaps are appropriately linked to work packages and plateaus, it is possible to select Generation of Architecture Definition Increments table from the BEASI menu. BEASI then generates a plan, which can be saved and imported into Microsoft Excel. In the example, we use the work packages and the transition architectures we've identified. We select the folder and go to the extension menu, select BEASI and generate Architecture Definition Increments table. We are asked to save the file, which we then can import into Excel. If you now just add dates to your transitions, you will have a rough work breakdown structure and a draft roadmap. The final feature we will describe is the possibility to use BEASI to generate TOGAF documentation. For the predefined project structure in BEASI, it is possible to generate TOGAF documents, such as the architecture definition document. In the predefined project structure in BEASI, there is a package called ADM deliverables. Here you will find a set of TOGAF documents. We select the architecture definition document, and from the project menu we select documentation and generate documentation. It is important to select an output file, but once we've done that, we hit the generate button and the document is created. This can take a while. The document is eventually generated, and once we hit OK, Word will open up and display the document.
That finishes our presentation. Thank you for watching, and if you want more information, please visit www.biner.se.